Hi everybody, I'm Donald Bailey. I'm a student at COTC, Central Ohio Technical College. I'm in a math class called 1215. It's college algebra with Emily Dennett. We're doing this video today to demonstrate a problem that we discussed in the classroom and how it affects us in real life as well. First, we'll go to the computer. I do everything on the computer, so what way better to teach you than on the computer as well. So we'll just go to the computer and I'll demonstrate how to do a problem. For today's lesson, we're modeling data with linear functions. Now the benefit of doing this is if you want to get your outcome of anything for a particular time frame, and then again later on down the line, then you can do that using these formulas. This particular example, we're doing egg production. It could be any country. For sake of argument, we'll use the United States. The problem states that the chart shows a country's annual egg production. Model the data in the chart with a linear function using the points of 4 and 59.1 and 6 and 63.9. Predict the egg production for 2009. Okay, with this chart we actually started in 1994. Now that'll be our x coordinate and it'll be 0. And 1995 will be 1. 1996 will be 2. And so on and so forth. Now the outcome in 1994 is 53.2 billion eggs produced in the United States. Now to create a linear function for this problem, we'll need to consider the concept of it being a line, and there'll be a slope to where the production of eggs will rise each year. We can use our points. 4 would be our x, or a year. That would be our point 1, or x1. 59.1, which would be the amount in billions in eggs produced in 1998. That would be our y1. 6, which was in 2000, or will be our x2. And 63.9 will be the amount in billions that eggs was produced in the year 2000. What we want to find out is in 2009. Now to do that, we'll have to use two separate formulas. The first formula will be called the slope formula. Now m will represent the actual slope in the line or the graph or the problem that we're solving. And how to do that is you put the change in y over the change in x. There's a couple different ways to look at this. You can either, it be y1 minus, because a change is a difference is a subtraction. You take y1, or y2, actually not y1, but y2 minus y1 over x2 minus x1. And what that will do is you'll get a slope. Now we already have our points for our first coordinate in an ordered pair. So then all we need would be a slope. Once we determine our slope, then we can plug in our numbers into what they call a point slope formula, which is y minus y1 equals m, or the slope, minus, or times x minus x1 in parentheses. Now to solve this problem, what we'll do is we'll take the points that were given to us. The first was 63.9. Well, we'll do this. This will be our top coordinate, or our y coordinate. We'll subtract 63.9 from 59.1, and that equals 4.8. Now, for our bottom part of our equation, or our division, you would actually take the 6 which was in your second ordered pair, because you always take the second first, minus your 4, and for that you get 2. So then you take 2, or actually rather 4.8 divided by 2, which actually comes out to 2.4. So 2.4 equals m, or our slope. So then, since we have our slope and we have our ordered pair, we'll just take the first ordered pair for sake of arguments, which was 4 and 59.1. Now 4 will be our x-coordinate, 59.1 will be our y-coordinate, as explained earlier in the graph. The egg production is your y, your year is your x. Since we already have our slope and we have our first coordinates, we'll go ahead and plug that into our equation. You always put y first, minus your first y coordinate, or y1, which is actually in this case would be 59.1. Set that equal to the slope, in this case was 2.4. Multiply that by x minus x1, in this case it would be 4, in parentheses. And this is our equation to produce a linear function, or a constant variable for our equation for those coordinates, and so we can determine the growth in the egg productions in the future years. After you plug that in, we'll just go ahead and use what they call the distributive property for their second half of this equation. Take 2.4 times x, which just generally essentially means 2.4 times x is 2.4x. When you multiply the second part of the equation, which is 2.4 times a negative 4, a positive divided by a negative is always going to be a negative, so we'll just go ahead and put our negative sign there. And 2.4 times 4 is 9.6. So this is our second half of our equation. After we solve that, our new equation would be y minus 59.1 equals 2.4x minus 9.6. Now what we want to do to get this equation into a linear function, we need to get it into a y-intercept form, which that formula would be, I did not explain it to you earlier, which actually means y equals mx plus b. B is actually just the term to say where your line or your graph or your production rate actually goes across the y-axis, which is the vertical axis on the graph. So in order to do that, we'll have to add 59.1 to both sides. Now to do that, we need to take 59.1 plus, we already got 9.6 on this side, is a minus, so we'll actually subtract 9.6. And after you do that, you get 49.5. Oops. We got to put the equal signs in there. So our equation, after we removed the 59 or the negative 59.1, we got rid of that by adding it to the other side, which was 49.5. So we just fill in the rest of the parts of the equation, and then that's our answer. We got y equals 2.4x plus 49.5. Now this is our formula that what we're going to use to determine the rest of our answer. We know that our year is our x, and our y is the amount of eggs that we produce in that given year. We know that the year of 2000 equals 6, and what they did, so on and so forth, every year add one number.